Okay, so yesterday we saw some more concepts in Java, like how to create variables. Actually, it started with the class concept, what we can put inside a class, like fields, constructor, and methods. We saw how to create constructors, how it looks like, and what's the purpose. Then we saw default constructor rule, how it works out. Then we saw methods, some examples on method. Either it could be simple method without any return type, like void something. Then we also method which can return something like this is the return type syntax for it. Then we talked about some more examples and how to combine like together like variable and method, how to return, how you can call them through object. Then we also discuss when you create a simple Java class. So by default, when compiler compiles a .java class into .class file, so it adds certain things. One other part is adding a default constructor if you are missing any constructor in your existing class like here. Then we talked about the essential thing, the important part, like how we or not we, when everyone says that Java is object-oriented approach or a supported language, because it follows these four basic things. So classes and objects definitely they are there. We already saw that in our initial classes, first and second. Now we are talking about some critical things about object-oriented programming, like four basic pillars, sometimes called. So we talked about inheritance and where we have Java concept, which is known as extends keyword through Java classes, and there's a implements keyword which is used by interfaces. So we talked about extend keyword where uh, child extends all the features from or inherits all the features from parent class. So how we did that? We created two classes, forest class and tree class, and then we use extends keyword. So initially tree doesn't have anything. It's empty. It's an empty method without any in terms of implementation, just a main method. Then we call that method and it works out. So this is what we did yesterday. Now let's continue from the same point. What if we have other keyword, the implements keyword. So as we know from yesterday's class that if we use implements keyword, so this works with interfaces. So how interface works or what is interface? Interface is like a we call that um, feature or kind of contract, I would say, contract between class and interface. So how it works? If interface, if there's some requirement, let's suppose there's an architect who wants to design some building or let's say some house. So that designer will say if definitely that will come into some software they will discuss where things should be like where should be the bathrooms the kitchen and balcony. I mean all that thing has to discuss. So what they are saying like how to design things. So question is how. So that goes inside in terms in if I talk about Java in interface. Sorry, not how, like what to be done. If this is how, so what to be done, how many rules there will there and what should be done for that, what kind of things has to be done. Then comes to like how it could be implemented. So that goes in a class. So let's talk about in a programming term. We have an interface, let's suppose, or requirement. So I will say first of all we have to create its interface in a kind of a layman term. So let's suppose I'm going to create a interface or not interface, some concept, or we are going to draw something, draw. Now, when we say draw, so when it comes to drawing, so multiple things can come up, like what you're up to, what you're trying to draw. So let's give a some narrow. We'll say let's narrowing that thing. I will say I want to draw a shape. But again, shape there are multiple types like circle, triangle, rectangle. There are multiple shapes out there. So what shape? So what I'll do to clarify that what I'm up to, I will create a class, and that class could be let's say circle. And then we can say when we say draw, so we are pretty sure when we draw it will come out as a circle because that's a class implementation. In future, if someone says, okay, I want a different shape, so no problem, change the implementation and say triangle. So now we have one more shape, but it's triangle. So if I say draw, that means triangle is going to be drawn. So interface is saying draw. It doesn't gives you a concrete implementation. It just gives you a idea of what has to be done. So how we can use this implements keyword here. So this is how it works. So when we have interface, so I'm going to so how to create interface first of all. So it goes like public. So there's a keyword interface, one more Java reserved keyword, and then you can call it shape. Then start body and body, and inside it I will create that method public void draw. It is coming up like how to achieve that inheritance. The difference between a interface and class is interface does not give the method implementation. So it means after creating method name, put a semicolon at the end. That's it. We don't give method body or method implementation. The role for this part is through Java classes. So this is how it has to be done. So if we have an interface shape and I'm going to create a class like circle, so it goes like public class circle implements shape. That's how it has to be done. Then whatever code goes here. Okay. Okay, so that's how we can implement it. So let's do this in Eclipse. So we have the OOS concept. Here I'm going to create a new one option. So we have option interface, create that shape, finish. Then I'll create one more, this time a class. I'll call this circle. Circle is there. Then circle is a class. So it says implements shape. Okay, now if I go back to shape, so let's create that method without any body. So public void draw. Usually I pick this example. This is quite simple to make this concept clear. So public interface shape, it has a method draw, and you can see we have a semicolon. If I try to remove that semicolon and give a body, I'll get an error from the Java compiler right away. What it says, abstract methods do not specify a body. Okay, fine. So we won't do that and put a semicolon. Okay, but as soon as I do this, let's close the extra files. So as soon as I do this change in shape interface, my circle class starts complete. It was not there earlier, but now it is giving. What it says, the type circle must implement the inherited abstract method shape.draw. So what I need to do, I'll say add unimplemented methods, and there we go. So as soon as we do this, you can see this method is coming from the parent itself. So Eclipse just pulled that method and wrote it here, and it also adds at override. You can remove it if you want. So for simplicity, I'll remove that annotation. Okay, and then I can give my own implementation because it's not possible to give implementation right here because it doesn't have a body. So I can just say sys out shape drawn. Oh, shape circle. Okay, great. So yesterday I told you that I'm keeping everything in same file, but now I'll try to segregate things. So this is in one different file, this is in one different file, and I will create one more different file to test it. So right click Java class, and I'll say circle tester, or let's, because I'm going to create some new shapes as well, so let's name it actually, not circle tester, shape tester. Let's rename it through here and done. Okay, and then here I'll keep that main method to test things. Okay, so the next thing is but that I'll give it as a homework. Let's put it here a little bit up. Here comes the homework. So first question is difference between class and interface. One difference I already told you guys, that method inside interface, they don't get the body. Okay. Next is next difference is we cannot create object of interfaces. That's true. If I go back and my interface name is shape, so if I write shape, variable name small, then new, and if I give shape, I'll get an error. What it says, cannot instantiate the type shape. Yep, it's not possible. So let's copy this line and I'll paste it right here. Okay, so it's not possible. Comment the entire line. So we are coming back to the next implementation, that is circle. So I can definitely create instance of circle, object, then new circle, and then I can call the draw method, circle dot draw. And yeah, because this method is right here, I can call this method. And how to call this draw method? By creating object of or instance of circle class. So I just did it here, and if I run this code, circle shape drawn. In future, as I said, somebody comes up with different shape. So, but the requirement is already there that you have to draw something. Okay, so I'll create a new Java class, triangle, let's say. So this guy wants to draw a shape. So I'll say, okay, if you want to do that, do one thing. There's a method inside shape, have it and give your implementation accordingly. So hover the mouse, click add unimplemented methods. Eclipse will drag that method for you, and here you can give your own implementation. But for the sake of the simplicity, I'm just writing one line methods, one line implementations. Triangle shape drawn. Okay, so how to test it? Again, we will go back to that shape tester. We'll create the instance of triangle, and then triangle dot draw. So two methods will get printed here on the console, one for circle, one for triangle. So yeah, that's how we achieve inheritance. Put this code on Notepad. So one or difference I already gave you guys. Next question is up to you. We have like 5-6 differences. Try to figure out the difference between interfaces and classes. This is for shape. This is for circle. This is for triangle. Okay, move a little bit left, and this is the test. So from this example, we saw how this method comes up as a child, as an implementation, and plus we cannot create instance. And if you try to do that, you will get the error from Java compiler. And below is the output. Okay, this is second, yes. Okay, so interface shape, and next one here. This is the main method. Okay, so we are done with the inheritance topic. Next topic in this line is take it from the image. So next topic is abstraction, like how to achieve abstraction in Java. Again, there are two ways to achieve abstraction in Java. So let's talk about it. Abstraction is all about data hiding.
Abstraction class and abstraction method, right?
Abstract class is correct. Next is through interfaces.
Abstraction.
No,
Okay.
method is a part of that process. So two ways. Abstraction is all about data hiding, where we kind of try to hide certain data, and it has its own significance when you are programming. So we don't want to like expose all of your implementation, just the actual thing. And
Okay. Yeah.
sometimes it helps us to hide some complex coding where actually we don't care about how complex that code is implemented. In future, we will talk about collection framework, and
Okay.
we already know there's a data structure, right? Data structure, lots of binary trees and implementation was there. If we have to actually implement it that through a program language, it will take a time, but we have a ready-made solution. So just call that method and it's done. So what's happening? Everything is abstracted there. You don't have to worry about like how that binary search is implemented or how that red and black tree is implemented in Java language. So that's where this abstraction will come in the picture. But yeah, that will come later. So there we'll discuss again about the abstraction. So in simple
Yeah.
terms, it's all about data hiding. Okay. So when we say abstraction, so we have two ways to uh, interface in Java, we'll say. And then one is I'll write interface first. Yes, again. So that means we already saw one implementation right there. And next is abstraction. Sorry, abstract class. So we have two ways in Java. One is interface, which we already saw, and next is abstract class. Okay, so how about interface? We already saw this, and in interface, we already saw by using interface we can achieve inheritance. And yesterday I already told you that if you are going to implement any of the feature, you will figure out that, or you will see actually that there are multiple. Like it's not just about one concept. Multiple concept will come up when you are trying to achieve one. So in when we abstraction, interface is there which provides abstraction. And how it comes up? Let's see this topic again. This example. So this is interface shape, and what we did later, we implemented circle class. Sorry, we implemented shape into through this circle class. So this is the implementation of draw method. If I just talk about and check this draw method, so we cannot guess at this moment the what the shape is going to be drawn. Or if it's not clear, let me do this here. So this example is clear. We are going to continue with that abstraction part. So let me do this out. Just one line, it will get printed on console. Let me show you how it looks like. Okay, so first section is just for inheritance topic. Now we are going one step further. After achieving inheritance, let's do one abstract call. Okay, so how it looks like, just a minute change and it will be kind of abstraction. So if I just write shape, we already saw this thing. If I try to do this, we get errors. This way. So we can see we are getting error from the Java compiler. It says you cannot create the instance of shape interface, and that's obvious. It's from the it's like a part of a rule of Java language that it doesn't support inheritance of uh, sorry it doesn't support the instantiation of any interface. Okay, that's fine. Next is what we got to circle. What if I instead of writing circle sorry shape, if I write circle right here, see, and now if I say shape dot draw, it is coming up. What is happening here? Now have a look. Uh, This is our center. This is left side. This is right side. If we just see right side, so we can clearly see the shape is of circle type. But if I just hide this thing, now think about. Let me hide this. Now, can anyone guess what shape is coming up? I'm just calling shape.draw. And shape is just random. It's kind of abstracted. You cannot guess just by reading this line, shape.draw. So at some extent, it is kind of hiding or achieving that concept that we are achieving that abstract call. If I just see shape.draw, you will never get to know that what shape is going to be implemented unless you have the this line. So when we come to framework level, so this kind of calls you will see multiple times because it's just a code Java, so you cannot see that full functionality in one go. But if you just focus on this shape.draw, so never no one can guess what shape is going to draw unless they have the this part of code. So this is just a reference, but this reference is holding up the actual implementation. So if I run this code again, it will say same circle message, circle shape drawn. Same thing I can do. I'll keep the same message and instead of circle, I will create triangle. So if it is a child class, it's possible. Only right side is the child class of this left section. Only then you can do this. And this time if I run triangle shape drawn. So just by changing the implementation, you can guys see here without changing anything on line 17, I can get different types of implementation. So this is kind of a abstract law we just achieve in through interfaces. Okay, now let's talk about uh, abstract class. By the way, one more thing about interfaces because I haven't like explained all points of interfaces. Interface by default gives the abstract keyword with their method. That means I have this draw method. There is a keyword in Java abstract. So by default, all methods inside shape are abstract in their nature. So if you see a keyword abstract with the method signature, that means that method is abstract. So to make things clear to most of the students, what I used to explain, if you see abstract, that means it's not complete in nature. Okay, not complete that means it doesn't have a body or it doesn't says completely its own implementation. So whenever you see abstract, that means it's not complete in nature. So if you connect these two terms, abstract means not complete in nature, so that will make you understand, okay, abstract means it's not there, it's there but it's not completely there. That way you can read it. So this keyword is optional. If you give it, that's great. If you don't give it, so compiler will add you, like it adds default constructor. Same way, if you don't give abstract here, so when this method gets compiled by Java compiler, what does it do after compilation? It will be read it like abstract here, this way. This will be after compilation. Compilation. Okay, so that this is about interface, so I don't need to create any new example. It's same thing. Okay, now next is abstract class. Okay, so this is done. Now we are talking about abstract classes. So how abstract class looks like? Let me write something on Eclipse. So let's close extra files. Right click, new class. Um, let's say I'm going to create one class house. Okay, not house. Let's say building. Name, enter. And if I mark this class abstract, this becomes abstract class. That's the first step towards creating any abstract class. Think about this building is in construction. It's not yet completed. It's under construction. So everything is abstract yet, right? Think about it. They're just planning. They have a plan, maybe they have some blueprints, and the workers, all the builders, they're trying to complete that building. So for a third person who is just watching that building, for them that building is abstract in the nature. They don't know where the stairs goes, where the lift goes, how many stairs will be there. Sorry, I mean how many lifts will be there. This old building will be residential or they will provide some office space as well. How many rooms will be there, like 2 BHK, 3 BHK, 5 BHK. So that everything is abstract for the other guys. Think about that way. So that building, this building is abstract in the nature. Okay, so I pick this class. Okay. So to achieve abstraction, first thing is inheritance. So I can even write here the prerequisite for abstraction is inheritance. Without inheritance, you cannot achieve abstraction. Let's extract out this box. Go here, paste. Okay, prerequisite. So if you don't have inheritance, you cannot achieve inheritance. So you should see there must be inheritance. So in case of interface, we just saw that without creating any circle or triangle class, there is no existing of shape. What I will do with this thing? It doesn't make any sense to me or not to anyone. What we will do unless we have a concrete implementation. So there's a term we tend to call this interface always needs concrete implementation. That's a contract. I mentioned, I think in here, no, in first image, I guess. Yeah, contract between classes and interface. Okay, so what interface needs? A concrete implementation. That means something which is complete in nature. Okay, coming back to image. So we have a abstract class building, and this will act as a parent class. Parent class. And to support that parent class, I need to create a child class, which will be complete in nature, a concrete class. So public class, let's say floor. So class goes here and then ends here. So this can be called as child class. This class will act as a child class for this building class. Okay, this is fine. Okay, now one big difference between interface and abstract class is about the at like how many percentage or at what level they provide uh, abstraction. So when it comes to interface, it provides 100% abstraction. When it comes to abstract class, it provides 0 to 100% abstraction. What does it mean? We will see through the examples. Everything should be from the examples. So interface means when we say 100%, doesn't matter how many methods you will create. You cannot give the method body. Like draw 1, draw 2, just giving numbers so you can see multiple methods are there. If I try to give any method body, compiler will complain. It says you cannot do this. It's not possible. So till Java 7, you cannot give method body. Okay, just put a note somewhere that till Java 7 you cannot body. From Java 8 onwards, we are allowed to give method body in certain circumstances that we will cover when we start with projects in Spring Boot, because these are some kind of a sensitive topic which is never getting old. Every time you facing an interview or working in any Java project, you have to answer this question, even to someone or maybe to yourself, that how it's possible and how you can achieve it. But this concept is still Java 7 that you cannot give method body, and if you try to do that, you will get compiler error. So I'll remain with that. It's possible. It's not possible. Okay, so this is known as 100% abstraction. So you cannot give any method body. It's not possible. So we have a building this. So public uh, void. I'm going to create one method. Um, let's say stairs. Okay, that's one method. This and semicolon. So it is complaining that something is odd here. This method requires a body instead of semicolon. So Eclipse is giving us two options. Either give the method body, that means give the implementation, or convert this method to abstract. So I will take this abstract keyword and error should be gone. So in interfaces, it's optional because it provides 100% abstraction. Either you will give it or not, the method is always abstract in nature. That makes it 100% abstract. But in case of abstract classes, it's not a case. If you write if you write abstract keyword, then only the method is abstract. In case if you don't give it, let me create one more method. Let's say lift there, and I can give method body. And if you are giving method body, you cannot provide abstract keyword. So I have to remove that. And here you go. It is working. So there we are getting 0 to 100% abstraction. Either you can give 100% abstraction by making all methods abstract, or you can give method body to all of your method and there will be 0% abstraction. See, everything's working. So there's a ratio and it totally depends upon how you want to achieve it. Well, it's quite rare to see that you are using abstract class in your regular programming. I don't remember when was the last time I saw in project abstract class are used for this kind of uh, task. We have some other ways which can be done by the frameworks. But yeah, this is a concept which you should know if you are beginning any programming language. So we will take 50-50 case. One method abstract, one method without. It is working. And here I'll just say this out. Lift method of building class. Okay, so we have 50-50 case. One method abstract, one is non-abstract. Okay, and let's close this one. Let's create one more class, which is going to be its child. It was floor, and this will say extends building. Yeah, it, it will take it, and as soon as I do, it will give me an error. What it says? Let's close this one. It says something is present in building which is not complete in nature. And if you see, this method is incomplete nature. It doesn't have the method implementation. So I'll go back here and over this and says, yep, only stairs will come up because as per the Java compiler, lift has the implementation, but stair doesn't have. So you have to give the method implementation in concrete classes. Floor is a concrete class. It doesn't support any abstract behavior. If you are working with any concrete class, that means method implementation must be there. Stairs from first floor. Just a random message. And our example is start. So we have a abstract class ready where we understood the keyword abstract, and we have a child class which is actually implementing abstract method coming from the parent class through this extends keyword. Now let's create its tester. So I'll create a third class where I will keep main method. So I will keep building and floor segregated, no mix up. And here abstract tester. Okay, I'll get main method done, and let's try to create instance of building first. Building equals new building, and then we will see error from the compiler. like we cannot create instance of interface. Same rule is for abstract class. So compiler won't allow you to create instance of abstract class as well because it's abstract in nature. So you cannot guarantee always that class will have all the methods. So if you have anything which is abstract in nature, compiler won't give you option to create its instance. So yeah, it's not possible. And if you hover, it will give you same message. Cannot instantiate the type building. Okay, so we cannot do that. Let's comment out and trying to create floor example. Floor class, I mean. Floor equals new floor, and then floor dot stairs. And if I execute this code, stairs from first floor. And I can also call the other method which has the complete implementation inside building. Lift. Okay, right click, run as application, and lift method of building class. Though I called it floor, but it is saying lift method of building class, and that's obvious because floor doesn't have its own implementation. It is just extending the feature coming from the parent class. So this method is obvious. It's not coming from the floor. It doesn't have lift method. It's directly coming from the parent class. So whatever is coming up, we have to just keep it as it is. Okay, so that's fine. And we have this lift method coming up. But yeah, we just covered the abstract keyword working from this example. Let me put this on paint. Some question or doubt you guys can ask in the meantime. Otherwise, we will move to next topic. Next, let's make it look. Okay, this is the fourth example. Let's take the output as well. So building class with 50-50% of abstractness. Example is done. Okay, so going back to the next topic, which is polymorphism in Java. So the third concept from object-oriented programming is polymorphism. Typo polymorphism. Okay, so polymorphism means many form. Like if someone breaks this term, so poly means many, morphism is form. So it stands for many plus form. So that's what this term means, polymorphism. Poly means many. So how does Java support this, and what are the ways get this? Again, there are two ways for in Java. So, or two types of polymorphism is possible in Java. One is compile time, next is runtime. Okay, so when we are talking about compile time, this can be achieved by, like example, how can we see this method uh, is achieving, or this polymorphism we are achieving at compile time. So compile time polymorphism can be seen when we do method overloading. And how we can prove that that Java is supporting runtime polymorphism by checking method overriding. So we will write two different examples to see that. Okay, so when we say runtime, what does it needs as a prerequisite? Again, inheritance. So prerequisite is again inheritance. So inheritance is quite popular, and this is one of the simplest concept from this object-oriented programming. So inheritance is needed when you are checking runtime polymorphism. Compile time is not required. Okay, so let's start with compile time thing. Let's close all in the same ops package. I'm going to create a class. We will say compile time test. Okay, compile time polymorphism tester. Big name, but that's fine. Just follow along the method signature and the method class name. It will be fine. Okay, so let's create two methods here. So, but that's a tester, so I'll keep main method here only. Let's get one different class. Let's say printer. Okay, that's my class name, printer class. So what does printer do? It prints. So on the basis of that, I'll say public void print. Okay, and so it will say printing. Simple enough. It says print, so it will printing. It says printing. Okay, and let's call this method here. So first of all, we need to create instance of printer. Then printer dot print. Okay, nothing special, just a regular class, printer, print method, and it prints printing. Fine. Let's run this code, application, and it says printing. Okay, cool. Nothing new. Now my requirement is, since its name is printer and definitely it should be printing, but now my requirement is I will give instruction like what it should print. Right now it's just saying printing, but we are not sure what it is printing. It's just saying printing. So I want to be sure that this should print that, not anything, just that. Okay, so how it's possible? One way is I can change the implementation. I will say okay, print A by C. But somebody says okay, I don't want any fixed thing. You can print anything like X Y Z 1 2 3 ABC. So that should be the case. If I change this implementation, so someone will not agree, and someone will yes say, and someone will say no. So to resolve that, what we can do, we can have one more method. We can have one more method which is print, but as soon as I do this, it will complain, the Java compiler will complain that what you are doing, you have a duplicate methods. You cannot do that. But I want to be sure that because if it's a printer, its work is printing, so it should print. So how to make difference between these two methods? One way is obviously I will change the method name, but that will remove that working or the functionality, or you can say concept of object orientedness. If you're using Java language, that depicts the real-time programming, that you are dealing some real-time things. So print is a real-time thing. So if you change something else, that will be misinterpretation. So what I'll do, I will change the or pass the argument. Now, as soon as I do this, you can see error is gone. So now that first person who was just saying just print, it will say printing. Now here the next case is I want to be specific, so it will say printing text. Okay, so now we are getting some more meaningful. So again, if someone says print, that means something is happening. But here, if someone calls this print, so they say okay, the text is getting printed. So let's call this one. So if I next time I'll say printer dot print, and I'll pick the next method, and here I'll say okay. So this is the text I just passed inside this method. Now if I run this code, run as application, it will say printing hey there, and first one was calling printing dot dot dot. Okay, now third person comes up. This okay, that's fine. It prints something, it prints hey there, but I want to print some numbers, some numeric value I want to print. So now we know the technique. If that person wants some numeric value, I will change the argument. Int numbers, or just number, and I'll pass that number here as a concatenation. And boom, yep. Still we have the same method, print, 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 but their functionality is different. So many forms, but different functionality. We have the same function, same names, same name, but different functionality. So this is one of the way to achieve compile time polymorphism. And I can call that third method printer dot print with number this, and I can pass 1 to 3. Let's run the code, application, and printing 1 2 3. So guys, this is one of the simplest example, and obviously you can find any example on the web. More or less you will see the same functionality. So keep your example to the point, so you can focus on the concept, not the content of the example. Try your best to keep examples simple when I'll ask you to write some code. Okay, and there goes the tester code. Put in the box. Okay, so we just saw what is compile time polymorphism and how Java supports that. So Java supports that by method overloading feature or functionality. Okay. Next topic is method overriding. So this is one interesting thing because it needs inheritance. So this is what we just did in this example. This is for compiled time. Okay. Next we are going to run write example for runtime polymorphism. Sixth. Okay, so first of all it needs inheritance. Okay, fine. So let's create one new class in oops package. Okay, that's animal. Okay, so I created a class animal. I'll create one class lion. Fine. Animal will act as a parent class, lion act as a child class because as I said it needs inheritance. And I will create one method public void age, or let me make it more that way name, so there we can see the actual significance. And this will say sys out. I'm not returning anything, keeping void, and here say name. Name let's say the name is shared string, huh? Okay, so the name is shared string for this animal. Let's say more unique animal. We will write that name later. Okay, so the method says animal name, that's it. And line is just extends animal class. Okay, so nothing special. We have a class, a regular Java class with one method animal name, and line just extends animal functionality. And let's create one class for testing. So runtime tester, like we have compile time polymorphism tester, this runtime it's a polymorphism tester. Okay, so for tester I need to have a main method. Done. Let's get instance of animal first. Animal equals, then I can call the method animal dot name, and if I run this code, it says animal name. Okay, fine, because that's the implementation. Let's create instance of line this time. So line equals, and I can say line dot name. If I run this code, again I'm getting the same name, animal dot name, and that's obvious because this method gets inherited to the child class, and line doesn't have a method, so it is just achieving that method or inheriting that method from animal class. So when we call line.name, this is not actually from line class, it is coming from the animal class, and it's all because of inheritance. That's the problem, because when we say line.name, we are expecting a line name. Okay, so what we can do? We can do overriding. What is that overriding? We call that method overriding. So we need to override the method coming from the parent class. So we go back. So the very first thing you have to maintain that the method signature should be same. So to ignore any kind of possibility of error, I'll copy the method, paste it as it is in line class, as it is. And then I will change the name. I'll say Mufasa. Okay, so now we gave a dedicated name to this line. It's Mufasa. And let's run the code again. Right click, run as application, and now you can see the Mufasa is coming out. So this time what we just did, we overrided the method coming from the animal class. And that's it. Yeah, this is one of the simplest functionality. If you understood how to create class, how to create objects, how to call methods, and then inheritance. So we just, using the same functionality in a different way to achieve some bigger things which we will achieve or see in upcoming classes. So this is from animal class. This is from the line class. And this is test room. That's the output. So we just completed 3 points from object-oriented programming: inheritance, abstraction, and polymorphism. And it's done. Last point from this list is encapsulation. That is encapsulation. So let's cover that, and this is one of the simplest functionality. And this could be complex, but for the simplicity, I'll just say something. So encapsulation, it means wrapping up the data into single entity. This is kind of a bookish term which I just by hearted because I read it multiple times. So this can be known as encapsulation, wrapping up the data into a single entity. Or now in my way, or in a simplified way, a container which holds multiple things, lots of steps intact. Okay, that's how I explain. So in our case, guys, from the first class, I don't think we remember we did first, but yeah, initially we did one thing. We created one important part of Java, that is class. Class some XYZ. So we saw this part that if you are creating class, lots of things are possible inside a class. Variable, methods, constructors, blocks, I believe you guys have done the blocks. If not, do that. It's weekend, so try to do that. Then in nested classes. So you can see a class is acting as a container which is holding multiple things. So same statements here, wrapping up the data into a single entity. So what's the single entity here? The class. And what's the data here? Variables, methods, constructor, and or other things. So we can say if you create a simple Java class, even a simple Java class with some methods and stuffs, you are actually achieving encapsulation. So for encapsulation, I don't have to create any new or some unique example or put up some new term for in front of you guys to make it understand, okay, this is encapsulation. No, not required at all. So if you understood how to create Java class and put things inside it, we are done with the encapsulation. So I always keep it at the end that you guys so it will be easy to understand that whatever the concept you have to like pressure on your head should come from these three topics: inheritance, abstraction, polymorphism. And encapsulation is quite simple if you understood three concepts. So we actually achieved encapsulation, and that's it from the object-oriented programming concepts. But here I just want to explain one important or initial thing. If any question on uh, object-oriented programming, so you can say now or maybe later when you are practicing the code. On core, let's do this. So here I'm going to put up a concept of POJO classes. POJO class. POJO. On POJO class. This stands for plain old Java object. So it means a class with private fields and public getters and setters. In simplest terms, that's how we can explain to you guys. A class with private fields and public getters and setters. This is POJO class. Okay, done. So you can do that. We will create a class. Okay, let me write the example for that. This is one terminology which is oftenly used. A lot is used in Spring Boot framework and any framework in Java. So you should know how to create that. And good thing is it's quite simple. And when it comes to implementation, how you are using it, that sometimes makes things complex. How to create it's really easy. So simply go to package, new Java class, and let's say shoes. Okay, so we have a shoes here. So statement says private fields. So let's make private fields. So int price and one more private string name. And so we have two fields private, and it says public getter setters. So one thing is I can write the entire getters and setters for both fields, or I can use Eclipse, the editor. So what you have to do, this is quite, guys, quite popular thing, and you will do this regularly in your programming if you are actually writing the code. So right click, source, and you can see this option, generate getter setters. Let's do this again. After adding private fields in your class, right click inside the class, go for source, and then generate getter setters. Click on that, check for which field you want to generate getter setters. After selecting, click generate, and Eclipse will generate getters and setters. These are nothing but methods: get price, set price, get name, set name. So we call them getters and setters. Getter for price, getter setter for price, getter for name, setter for name. And this class is a perfect example for POJO class. Okay, just did that. Let me wrap it this way. Actually, let me extract it in next image. And let's use this class as well. How to use it? So not a big deal. I can create a new Java class POJO tester. Main method. So first of all, we will create instance of shoes. Wrong name. We shouldn't call it shoes. It should be shoe. Name should be in a singular way. Not we don't provide in a plural names. So it should be shoe. Finish. Okay. Always remember this. We create class with this way shoe new, and then I'll say shoe dot set. So what I will do, I will set the name. Let's say okay, then shoe dot set the price. Say 1500, whatever the price is. So what we just did, we created instance of shoe class and then set two fields. Usually when we use frameworks, so these fields should be auto set. But as we are just using core Java, so you cannot do much. So we'll stick to like manually setting the price or another field name. How to get it? So same way you can just say shoe dot get name, and I'll wrap that inside sys out. So in one statement it will get printed. Sys out. Oops. Put a message as well. Show name is name or brand, whatever you want to call, and then price is, and here I'll get use the getter of price, get price. That's it. So if I run this code, shoe name is Nike and price is coming up this way. Giving a space, it looks better on console. Okay, so that's how we can use getters and setters, and this is quite common practice in day-to-day developers development. So whenever you join any project, even when we create project, you will see this is quite common practice. We have to create lots of sort of setters and getters. I mean, we have to create lots of POJO classes. This is our next example. It's also done. One more thing I want to cover here, and then we can wrap up today's class. So let's going back here on show class. Later we'll do that. So once we are done with this whole thing, I want to print something. We are creating object from second class. It's like fourth class. So we actually are kind of habitual, and now we are much familiar with how to create object or how to create instance of a class. And this is its signature. Class name, a reference variable, then equals, then new keyword, and then constructor called. Default constructor is called. Okay, what if I try to call or print this one, the reference name? What if I just say SHOE, the variable name, this one? This I'm trying to print. What will happen? Let's create a difference here. Shift out. Okay, let's run the code, and it says compact core. Okay, this doesn't make any sense to me, but I can see it's compact core. That's my package name. SHOE, that's my class name. Then after some at sign and some weird thing is coming up. Hmm. Okay, I'm not sure what is that. So, okay, let's not do this. But I want some meaningful information from here, because every time I have to create getters for this thing to get one field, because I have one method is get name, one method is get price, and then I can get the fields. So idea is if I want something meaningful, I want to print when print when I try to get SHOE, so I should print the values of name and the price. So what we will do, we'll go back to the class, and we have a toString method. So right click source and again generate toString, and you have to print, you have to actually select which field you want to print on your console. So check the boxes and generate. So Eclipse will generate a method, public string toString, some automated fields. And now you guys will see the difference. I'm going to run this code one more time, and now see what's happening. Just by overriding the toString method. Yes, I said it correctly. Overriding the method. But if you guys notice, we don't have any superclass here. So what I'm overriding? Anyone? This is the question. Please unmute and answer it. I gave it as a homework. So what I am overriding here? What's the parent class? I haven't mentioned anything here. Vamsi, please tell me. Who else is here? Farah?
You are overriding the shoe
No. Overriding
so that
toString
it
method.
can.
Not sure? Vamsi, please unmute and tell me. Okay, okay. Farah, thanks. No? Having mic issue? Okay, so when we override toString,
Not really sure. Okay.
okay, fine. I give something as a homework. Let me just see first of all. Where is homework section? This is first class, okay. I think I asked you guys to do every day your homework. What is object class in Java? Superclass of every class created in Java language. I wrote it in front of you guys, and that proves still something is missing. You guys should be sure what I am saying, because whatever I'm teaching, I give this kind of you can say flow to you guys, that if I'm giving something a homework, that means next day or maybe day after next day, I'm going to cover that in my class. So homework is actually a signal that this is going to be covered in future classes. So if you have actually done the homework, you can see I ask you to go through this object class. So when you are not creating any parent class of your class, object class is there, and object class has one method toString. We just override that method, and once you override, you can get some meaningful information from that class. So try to cover all the homeworks I gave. It's Sunday tomorrow. Um, Try to utilize it and cover all the homeworks. So in this example, we created a POJO class and overrided one method from the object class. And when you print this, it actually calls the toString method. For us, it looks like this, but actually, when compiler sees this, it is saying shoe.toString. This is compiler code. And even if I run this code this way, it will print it two times. First here, because compiler knows that you are not actually calling the reference, you are actually calling reference.toString. So by default, this is the conversion. You are saying shoe, but compiler treats it shoe.toString. So when you don't give or override toString method, it gives the implementation coming from the parent class, like we saw in animal and lion example. When you're just calling name method and shoe doesn't have the toString method, so it calls method from parent class. So if you say object class, this is the object class. It was introduced in 1.0. And if I search this method, watch it closely, guys. ToString copied. I'm in object class. Control F, paste. There it is. See, get class.name at sign. And we saw something similar. It was printing package name, class name, and then at sign, and then some hex string code or hexadecimal codes. Let me comment this method. that line, executing the same code again. See the output. Let me copy this. And then this method line. So check out what we have. So com pack core, this is till here, it's here, then at sign, that's here, then integer hex string. So this calls one method which generates this part. So you guys can see when we are not implementing the or not writing that toString method, it calls the method from object class and it gives this implementation. This method is returning string. But as soon as we override that method, the implementation coming from our class only. So I hope this makes sense, and try to cover some methods from object class and check out what other methods are present in the subject class. Let me check where I gave the homework. Adding some more points. Okay, difference between this. Then next question. Difference between abstract class and normal class. Then same difference between abstract class and interface. Okay. Next, try some keywords like this. Last time I gave static, so I'm writing it again. So if you have missed, try to write examples on this static keyword and see some theory part. So static keyword, this keyword, check these keywords out, and now check out public, private, protected, and default. We call them access specifiers. So check out these things as well. And if you guys are done with this concept, we are pretty much done with the basics of core Java. So if everything goes fine, maybe on Monday onwards, we can start some new concepts, most probably exception handling. So any question dot? Otherwise we can wrap up the class.
No, Pankaj.
Okay.